count with me the number of terms. Ready, set, go. So this is a trinomial. You can, of course, just use X box factoring and get the answer, okay? But let's just say it becomes more difficult and the polynomial is way bigger. You can always use the rational roots theorem. In the rational roots theorem, the first thing I told you guys for your steps is to do what? Find the GCF. Is there a GCF in that problem? No. So I know there's two slides. There's the factoring, and then there's the rational roots theorem, right? We're just applying the rational roots theorem. So let's find the factors first. So our last factors go on the top. So let's write that. Last. What are the numbers that multiply to be 2? 1 times 2. And the first, we'll go right here. So the first factors, what number is their class? 1. So we're saying that the numbers that multiply to be 1 are just 1. And what this looks like is that basically we can pick a combination of, from here, what's step number 2? We're going to divide. So if you look here, this is, you're going to have a plus or minus. And when I connect this to your X box, it'll totally make sense to you. So let's divide. 1 divided by 1. And 2 divided by 1 is 2. What's the third thing we have to do? Cross off any. Do you guys see any duplicates? No duplicates. Okay, what does this mean? We're now going to test these. So this is a positive 1, positive 2, negative 1, and negative 2. We're going to test all of these using synthetic division to figure out which one of these is a factor. Okay? So count with me. Ready, set, go. And then negative 1, so that's 3, and negative 2 is 4. There's only 4 numbers to test here. Okay? Does someone want to pick a number for us to test? Okay, let's try positive 2. So I'm going to try positive 2. So if you want, basically all these numbers are positive 1, positive 2, negative 1, and negative 2. And my green here is, we're going to test, what did I say? Negative 2? Let's test negative 2. Remember my coefficients for synthetic division, 1, 3, and 2. What do I do with this 1 here? Now what? Multiply, what do you get? Add down, what do you get? Multiply. Add down. 0. Okay. What does this mean? It means, because it's 0, someone already pointed out, it's a factor. It means that this polynomial one of the binomials, if x equals negative 2, what's the binomial? If x equals negative 2, how do you make that equal to 0? Well, I'm going to move the 2 away, so I have to do what? So x plus 2 equals 0. Okay? Okay. What does this mean? plus 1, yes? It's a constant. What does this one mean? 1x, yes? Let's use pink. So the one that's left over here is our other binomial. So if I ask you to factor that, super easy, you get x plus 1. And this would be your answer. Now this is a pretty long and complicated example of the rational roots theorem. Did I say complicated or easy? This was a super easy example, but you're like, Mr. Ng, how come you didn't just use this? A times C is 2. The B value is 3. All the combinations of numbers that multiply to be 2. Positive 1 times positive 2. Negative 1 times negative 2. Do you see that? Class, would negative 1 and negative 2 work? No. These also would show that its factor is not equal to 0 based off synthetic division. Okay? So basically we're using rational roots theorem to factor more difficult polynomials.